Hello students, today we are looking at standard form. By the end of this video you should understand the rules of standard form and you should feel confident converting between ordinary numbers and standard form numbers. Okay, so let's have a brief overview of why we use standard form. We use standard form when we encounter very large numbers. For example, this very large number. It helps us to reduce the number of mistakes we make when copying or typing a number. So if you were asked to type this number, especially if it didn't have any commas in, there's a very large chance that you'd make a mistake. Or if all day your job required you to type or copy very long numbers like this, there's a possibility that you'd make an error. So this is the reason why we use standard form. This is the alternative if we were to be using standard form. Now there's not much room for error if we were to write all our numbers like this. But there is one rule we have to follow when we use standard form, and that is that the number to the left, so this number here, has to be greater than or equal to 1, but less than 10. So this standard form number fulfills this criteria. It's always times 10, and then the power can vary. The power can be positive or negative. So, converting standard form. Here are two examples of large numbers and small numbers which convert to standard form. Let's have a look at the first number. This is a large number. To convert this to standard form, we count the number of spaces required to move the decimal from where it is to become in front of the first digit. So, here's the decimal, and here's the front of the first digit. So how many spaces is it? 1, 2, 3, 4, 5. So it's 5 spaces. So we know that it's times 10 to the power of 5. Now, if we were to move the decimal like we just did, it'd be 7.56000000. Now we know that's the equivalent of just 7.56. So now we know it's 7.56 times 10 to the power of 5. Now what about the small number? Well, it is a similar process and we still want to move the decimal to be in front of the first digit. So here we can write this out again. So it's slightly larger. 0, 0, 0, 5, 5, 4. So here's our decimal and here's our first digit. So how many spaces is it from the decimal to the first digit? Well, we can draw this to find out. 1, 2, 3, 4. So now it's times 10, but because it's smaller than 1, it's a decimal, we use minus. So times 10 to minus 4. And then we imagine that the decimal was there. So it's 5.54 with lots of zeros behind it, which we know is the equivalent of 5.54. Okay, so now we're doing the opposite. We're converting from standard form to ordinary numbers. Therefore, we have to do the opposite. When converting positive powered standard form numbers or large numbers, we have to write out the number again, but with lots of zeros after the digit. So this is what we can write. So it's still 3.6 and then lots of zeros after the digit because we know it's going to be a large number. And then we can see that it's to the power of 4, 3.6 times 10 to the power of 4. So we move the decimal 4 points right. So 1, 2, 3, 4. So then we write out the number as if the decimal point was there. So it's 3, 6, and then 3 zeros. 0.00. So this is our answer for our first question. But what about a negative power? Well, it's not that different either. So because we know it's a small number, we write lots of numbers before the first digit. And then we look at the decimal point and we want to move it backwards 3 spaces because it's negative 3. So we do 1, 2, 3. So our decimal point will now be here. So if you write out the number again, 0.0042, and we know this number here is equal to 0.0042. So this would be our answer for our second question. Here are some questions. If you'd like to attempt these, please pause the video now. The answers are now placed on the screen. There's a second part of the video where we look at operating with standard form numbers. If you'd like to check out that video, the link will be in the description. For more videos, please visit www.gcsemathsresources.co.uk.